Okay, sure, sir.
Now you can start introducing, please, if you come back.
So now over to you, sir, and you can share your screen. We will start our workshop. Thank you.
Thank you, Mr. Nikhil. The number is now 79 engineers. Hello, everybody. Assalamu alaikum. How are you? I hope that this introduction session will be of high benefit for all of you, or most of you. Some guys are students at the university, some are new graduates, some are experts, so we will go through our course as we can. This session is an introducing session for a 3 weeks course. So this is our material. This is the course, Well Intervention Operations course, presented by Engineer Samer Sukhri. Today is 30 of April 2023. I hope that you will enjoy. This is under custody of Petroleum Engineers Association, Mr. Nikhil. Thank you very much. I want to introduce myself to you within 1 minute. My name is Samer Shukri. I am petroleum engineer, graduated in 1995. I am Turkish, experience more than now, if we calculate it, about 28 years. So I didn't change it, no problem. In the oil and gas, the work experience, I work over well services, drilling, production engineering, well integrity, IWCF. I am accredited IWCF instructor from Aberdeen, from Scotland, UK. I deliver courses for both drilling and well intervention. Well intervention means wireline, coiled tubing, and snubbing. International instructor, I have training certificate from UK. I worked for several reputable oil companies such as Shell, Abu Dhabi company, ADCO, and other companies. In the last few years, I am focusing on training and delivering courses over the world. I like you to visit my LinkedIn profile. If you write my name, Samer Shukri, here, or on YouTube. Also, I have more than 1,000 subscribers on YouTube. My lectures are there. You can visit it, and you will get much benefits. I am guaranteed. The course is focusing on well intervention in general, but we don't limit ourselves by well intervention only. We'll go from A to Z in the oil industry, oil and gas industry. You will see everything from seismic till abandonment, including drilling, including completion, including cementing, including casing, including workover, well integrity, including coiled tubing, wireline, electric line, slick line, snubbing. Also snubbing, it is rarely used, but I give courses. I deliver courses for snubbing, but the number is very little, not that much, same as coiled tubing or wireline. We will have duration 21 days, a 3 weeks course. Every day we will have 2 hours. We will say from 6 o'clock till 8 o'clock Turkey time, for example. Mr. Abdul Wahab, we can write your question. If you have anything, write it down on your paper, and at the end, I will take all your questions, even if I stay for 2 hours. Don't worry. Okay? This is for everybody also. If you write down your questions, I will answer all your questions as I can. Start time, end time, it will be from 6 till 8, for example, or from 4 till, we will agree on the way forward after the session, because our attendees will be from the worldwide, from all the countries in the world. So break I don't think we didn't need a break. It is just 2 hours in the course for three weeks. So every day we will have 2 hours. At the end, we will have about 40 hours. That is very nice, not bad. Interaction, I need your interaction. I will give you questions in the beginning of the course, and you will see your knowledge. Before we start the course, I will give you questions without answers. What do you say? That will cover the whole course. So at the end of the course, you will see the difference between before and after. I am guaranteed that you will see much difference in your knowledge, in your experience, because I am transferring the 28 years of experience to you within 3 weeks. It is not easy at all. So you will be happy, and in the meantime, some stress will be against you. So I need you to be patient. More patience is required from your side. So we will discuss, and interaction is very important for me. If I feel that you are sleeping, I will stop. So from now, I tell you, I need your mind. I need it to be open all the time to study after the course. Because if you don't get benefit, I will blame myself. That is not good. If you are spending your money, you are spending your time. Maybe your family needs this time more than me. I know this, but you have to improve yourself, because when in the oil and gas industry, our money is our mind. As you know more, your qualification will be more. This is the difference. Other guys, their money is maybe building, maybe car, maybe, but for us as engineers, technicians, managers, operators, anything, here is the anything. So when you go to any company, for Shell, for ADCO, for Aramco, for everybody, they don't tell you, give me, where is your car, where is your heart? They ask you and you answer. So if they ask you 10 questions and you answer 10 questions, I am guaranteed that they will choose you for the announced position. For example, production engineer, drilling supervisor, and so on. So you have to learn and be patient, and you will get it very simply. And I am guaranteed that you will be happy at the end of the course. So this is the course content discussion. Questions and answers. I told you, I will give you the questions in the beginning, then slowly you will get all the answers. Quiz also to be sent to you. Data collection responsibility. Who will take who will be responsible for this day? For example, Mr. Hiron. Tomorrow, Mr. Abdul Wahab. After tomorrow, then we will combine them together and say that we have, this is the summary of the course. You cannot go and watch the videos for 40 hours or 50 hours. You need summary. This summary may be 10 pages, 20 pages, or more or less. So you can review them. If you have any interview, if you have any position open, if you have anything, then you can go and you will be very relaxed, because you are taking the, what do you call it? The butter, that is the summary of the subject. So you will know the answer straight away, because in the past we were interviewing the people to join our companies. So these questions and answers will be transferred to you. Daily duty also, I will give you what shall we take tomorrow and any suggestions. Then here we can go through the subjects. Introduction. We will go into introduction, how to get oil and gas and how to recover them to surface, completion equipment and operations. This is including what? Seismic and the drilling. This one, this is the first one. This is completion equipment and operations on the rig. This is on the rig, drilling. Well control principles, if you would like to do IWCF course or IADC course or any type of these, so I will support you and you will be expert at the end. Well intervention methods, we have too many, 5 main methods, including coil tubing, wireline. The wireline includes slick line, braided line, and electric line. Number 3, snubbing or hydraulic workover, HWO, hydraulic workover. Here we have workover. It is under either well intervention or under drilling. Some companies put it under drilling, some companies put it under well intervention or production engineering. Then well testing. Well testing is very, very important. So I will give you golden rules and golden principles for this well testing. You will be very happy because I like and I love well testing too much. So I will spend maybe 2, 3, 4 days as you like and give you all the secrets of well testing. For coil tubing, we will go through these items. What is coil tubing? The birth of coil tubing technology. Advantages of coil tubing, because sometimes you cannot use wireline if the well is deviated or highly deviated or horizontal. So you have to use coil tubing. If you want to pump fluids, barrier theory of coil tubing, we have primary, secondary, tertiary barriers. Calculations, we have too many calculations. Pressure testing, how to do pressure testing. Emergency procedures, about 10 procedures we have. BHA components, bottom hole assembly. We have maintenance. We have coil tubing, manufacturing, and material. Coil tubing onshore, coil tubing offshore. There is a difference between them. The space is very limited in offshore. So we have not truck mounted, not a trailer mounted here. Here we have trailer mounted onshore. But here we have truck mounted. You see? Here trailer, here truck, by lifting here. They give you on the offshore rig or platform. This is 2 times 2 meters for you. You cannot take more. Or 5 by 2, for example. So you have to know where to put your equipment here or there. It is not open like desert. You can put wherever you want. No, that is not allowed. Also, coil tubing crew members, we'll talk about them. Supervisor, coil tubing operator, wireline pump operator, nitrogen operator, and each operator has his assistant. And there are some helpers. Coil tubing unit diagram, also we have diagram how to rig up. Coil tubing unit rig up. We have forward circulation and reverse circulation using coil tubing. So if you have forward circulation, in this case, you should have a double flapper check valve in the BHA of the coil tubing. Otherwise, if you want to do reverse circulation, you have to remove this check valve, and these have this forward circulation has some applications, and this reverse circulation has another applications. We'll go through them one by one. So the equipment of the coil tubing, also reel, power pack, injector head, pressure control equipment, BOPs. We have these types, 4 types: surface lines, choke manifold, control cabin, nitrogen unit, pump unit, tanks, batch mixer, chemicals, fluids. Here also, what are the applications of the coil tubing? We have unlimited applications of coil tubing. It is the best invention in the oil industry, the best invention ever. Why? Because we save working using workover or drilling rig. If you want, you can do this job or operation within 1 day, and it can cost you 10% or 5% of the drilling cost. You will be very lucky. And that's what happens. We'll go through nitrogen lifting, acid stimulation, acid frac. I saw many frac people here in this course. So we will focus on the frog also. We have two types of frog. We'll go through them. Sand clean out also, and a possibility of getting stuck. We have perforation, three types of perforation. We'll go through them: open and closed SSD, milling, fishing. I will give you a study case also for fishing, milling, and videos. And I think 3 weeks is very little. So well, I don't know what to do, but we will do our best. Displacement of fluids, drilling also using cold tubing, acid wash. We have scale clean out, logging, circulation, and production. Here the cold tubing also, we will take we'll take emergency procedures for all of these cases. For example, cold tubing parts above the injector head or gooseneck, cold tubing parts below the injector head or gooseneck, and so on. We will go through them one by one. And what to do in case of you have this case. Study cases, all of these happened with me personally, and I like to transfer what I have had in the past to transfer it to you, to add it to your knowledge. For example, while we were working with cold tubing, the cold tubing got stuck while cleaning out operation. This happened with me, and I tell you what we should do in this case. A leak in the cold tubing at surface, cold tubing cut by itself downhole, cold tubing got stuck in the open hole, leaking of a stripper during nitrogen lifting, pinhole in cold tubing between gooseneck and reel, fishing of a stuck wire line plug using cold tubing. Here I did this fishing, and we were rewarded because there was a big problem and the well was closed for 2 weeks. So when we retrieved it with cold tubing, this stuck wire line plug, we were rewarded, and thanks letter was given to us, me and my crew. Let us move now to slick line operation. I told you wire line includes 3 types: slick line, braided line, and electric line. This is a slick line. What is a slick line? The birth of slick line technology. Advantages. We have barrier theory. We have primary, secondary, and tertiary barriers. We have slick line sizes. Also, the main sizes are 0.108 and 0.125. There is less and there is more. Pressure testing of the equipment. Emergency procedures, BHA components, maintenance, and inventory. Here we have inventory also. Slick line manufacturing and material. Slick line onshore and slick line offshore. Here I told you it is a trailer mounted, here truck mounted. So by lifting here, like a box, and you put it, same as cold tubing. Slick line crew member. Normally we have 3 guys: supervisor, wireline operator, a crane operator, and helper or assistant. So 3 to 4. When it is a big size, you should have 4. But when it is small, you should have 3. Slick line unit diagram also. Slick line unit real. Here, slick line, we have these pieces or components of the slick line equipment. We have a truck, we have a drum, power pack, pressure control equipment. The main pressure control equipment components are stuffing box, lubricator, and BOPs. BOPs, we have single and dual here. But with coil tubing, we have 4 types of BOPs. Control cabin and a crane here. Sometimes we work with the slick line on the rig. So this crane will not be included in the rig up. We will use the hook of the rig. Slick line, we have too many applications of this slick line. For example, before we send any coil tubing to the west side, or we want to check the accessibility, we run a drift gauge cutter. We run it to check the accessibility, whether you have a scale, you have sand, you have any obstruction, you will discover it and avoid further problem. Set and pull subsurface safety valves, open and close SSD, set and retrieve gas lift valves, scale removal, tubing punch. You see, each one of these, I will show you the tool and the principle of it. How does it work? If you have any problem, how to avoid it. So you will be as if you are working personally. But without it, this will give you a background. But when you go one operation, two operations, you will seem as if you are expert 30 years ago. So don't worry about it. It is very easy. You see too many things, but by time, two operations for 1 month, say 1 month, you will be expert because you have good knowledge, good experience from these courses. Courses such this course are cumulative. What do you mean cumulative? Course, above course, above course, you will go up. While if you are sitting like this and watching TV or listening, or what shall you? No benefit. So you have to do more efforts on your side, on yourself to improve it. Tubing punch also, I will show you the tool that makes tubing punch. A tubing integrity check also, the tubing may have a hole, maybe cracked, maybe split, maybe tag TD, total depth, assist well completion operations by setting or hanging a plug. Sampling also, I saw a sampler here in the course, just wrote. We will talk about sampling. Isolate zones by setting flow control devices, run tailpipes also, chipping ice or salt, this is obstruction, paraffin cutting by using gauge cutter, running production logging tools for different logging types, bottom hole pressure and temperature surveys. This is very important. This is very, very important. Number 16. Now, the emergency response procedures for slick line will take these also, all of them, 9. I gathered them and I will transfer the knowledge to you. Stuck slick line, what shall you do? Part slick line, repeated jarring up and down for a long time. We have also how to cut slick line in an emergency. We have a procedure, special procedures, five steps. So if you don't know, if you know 3, it is not a complete answer. So you have the whole procedure as 5 steps. A slick line got out of the well, slick line got out of the wire line tool string. Sometimes it gets this slick line out of the rope socket. Rope socket is the connection between tool string and the wire line that is available on the drum. So it can get out. What shall you do? Leak from pressure control equipment above VOP. Also, this is very dangerous, especially if you have H2S, hydrogen sulfide, or you have high pressure, or you have gas, or leak from below VOP. Also, this is a procedure. Stuck tool string across the Christmas tree. What shall you do here? This is very dangerous situation. Hydrates like snow or like ice, forming during slick line operation. We can pump glycol or methanol to remove it. This is number 9. Then study cases for slick line. Here we have also the tool string got jumped after opening the SSD. This is, I'm adding it from my experience, practical experience. It happened with me. So it is easy to explain to you what is wrong and what should we do in this case. Leak from stuffing box, leak from lubricator, hydrates forming in the pressure control equipment at surface, failure to pull stuck plug and then cut wire line using wire cutter, weight of tool string has dropped while opening well while opening the well during wireline logging operation. Wire has cut downhole by itself and drop downhole, then we can fish it. So all procedures to take, we have to go into them in details. Let's move on to braided line. What is braided line? The birth of it, advantages. We'll go through them one by one. The theory of braided line sizes. What else? Pressure testing. We have also emergency procedures. We have BHA components, bottom hole assembly, maintenance, manufacture and material, onshore, offshore, crew members, wireline unit diagram, and wireline unit rig up. Here also the applications. How, when, where is it? Electric line information also. This one, we reach to here. What is electric line information? So I told you we have wire line 3 types: slick line, braided line, and electric line. This is braided line. We have inside it, we have only metal. There is no conductor in the middle. So there is no electrical signal transfer from surface to bottom and from bottom to surface. This only to apply more tension. If you get stuck with wire line, with the slick line, then you can use braided line. But for electric line, this one, we have to run in the hole and obtain the surface readout. What does it mean, surface readout? SRO, we call it. Mr. Fidel, you can write down your question, and at the end of the session, I will answer you. Don't worry about it. This is for everybody, please. Electric line, also, what is electric line? We'll go through it. It is wire line. Look at this one. This is wire line, similar to braided line, but in the middle, you see this, the middle, we have conductor, a brass line. This conductor can send electrical signal from surface to bottom and vice versa. And we can get surface readout. For example, if the pressure and temperature are X and Y at the formation at the depth of 10,000 feet, then we can read it. If the flow from this zone is 1,000 barrel, we can see that the well is producing from this zone 1,000 barrel. If it produces water, gas, oil, whatever, we can see it. So we can use this one. We call it electric line. So what is the birth of it? Advantages, theory of electric line, sizes. We have 2 main sizes, 7/32 and 3/4. So 2 sizes, same as braided line. Pressure testing, also how emergency procedures, BHA components, maintenance, manufacturing and material, onshore, offshore, crew members, diagram and rig up. Here we have problems. Here the applications. What are the applications? The main applications are these: 11 applications: open hole and cased hole logs, set bridge plug, tubing and casing punch, tubing integrity check using corrosion log, perforation. This is very, very important, perforation. Assist well completion operations, downhole sampling, run and set permanent packer, running production logging tools for different logging types, bottom hole pressure and temperature surveys. This is very important. Dump cement downhole using cement baler. Also, we send electrical signal to the cement baler, then we can open it and dump the cement. Study cases, we have 5 study cases for the electric line. Blowout of tool string after perforating. Tool string got stuck in the open hole. Bird's nest also of electric line in the grease injection head. Leak in the grease injection head. Tool string got stuck in the tubing and got wire from the weak point. So this is very important. How do you calculate weak point? Also, let us move to hydraulic workover or snubbing. As per my knowledge, it is rarely used, but I am accredited from IWCF to deliver this course as part of IWCF. So we deliver 3: wireline, co-tubing, and snubbing. So this is very important, and I will make you expert during the course. How do you deal with it? How can you take the certificate and be certified with hydraulic workover? I know that in Algeria they use it, hydraulic workover. It is very easy. I will show you the principle, explain to you. Maybe we spend 2 or 3 days on it. So this subject is very interesting and I like it. So what is snubbing? Hydraulic workover. Birth of snubbing technology, advantages. So you don't need to move a rig to here or workover. You are working on hydraulic workover. You will see hydraulic workover. That means you don't need to kill the well. If you want to kill the, if you need workover, you want to kill the well. But here, hydraulic workover, what does it mean? It means that you are working under pressure. So you have a pressure from A to Z during the whole operation. So how can you deal with it? How can you deal with the pressure coming from the inside of the completion and from the outside of the completion? All of them, we will go to them. The advantages also. Barrier theory. What are the barriers? Internal barrier and external barrier. What are the BOPs that we can face in this hydraulic workover? Pressure testing, emergency procedures, maintenance, manufacturing, and same as before, also rigor. Snubbing applications. We have 3 main applications for the snubbing. What are they? To install or remove tubular from a well while the well remains pressurized without killing the well. This is very important. Also known as a live well. Or maybe the well has a 3000 psi and you don't want to kill the well. But with hydraulic workover, you can replace the completion within 1 day or 2 days. So why shall you make damage to the formation? You may make a skin effect to the formation or like this. Snubbing is used when it is not possible or not desired to kill a well, dead well. The third one, killing a well, means depressurize the well by pumping a heavy fluid or mud inside the well. Also, if you want to protect yourself, you can pump what? Heavy fluid or mud inside the well, then it will go down and you will protect yourself. Workover. Here, workover is very important also. I saw many workover supervisors. You are working. We'll go through them. Normally, I deliver a 1 week workover course. This is important course, 5 days. But for you, I will do my best to spend 3 days just to balance between other subjects. What is the birth of workover technology, advantages, barrier theory for workover, pressure testing, emergency procedures, maintenance, manufacturer, onshore, offshore, and diagram. I will show you the types of the workover rigs that are available in the world, and we can utilize them. Workover applications, what are they? We will take these 10 applications. The first one is change out completion string. This is the most famous one. Deepening the well. Dig the well deeper, maybe 50 meters, 100 meters. This can be done using workover. Carry out acid stimulation using tubing string, casing repair by pumping cement here, and then check pressure test and check if the damaged casing is repaired or not. Pull and replace casing, isolate depleted zone using cement, set liner, zone change, fishing operation for different components in the well, and kill operation. Here, if you go to anyone from these, you see, you press control and this, you will go to full description of the what? Of the component of the rig. For example, drilling line. For example, cat line, boom and hoist line, drill pipe. You will take photo and what? Information or details for everything on the fuel tanks, water tank, blowout preventer, BOP, and so on. So here we have this one, these parts of the rig. So when you are talking about workover, you are talking about a drilling rig. So they are very similar. This is small, this is big. This is the difference. Here we have brake bands, casing head, cat head, and so on. You see elevators, drill bit, you see drilling rig. Also, you can use it on the workover also. Desander, degasser, sealer, and so on. Kelly hook, hoist line. You see how many items? 61 till now. Rotary table, Kelly spinner, Kelly bushing, slips. So we will go through them and you can see full details, swivel, for example, substructure, standpipe, and so on. Walkways, weight indicator. So 61 items for the rig, you will cover the whole rig. You don't want to go here and there. You will see them in 3 slides. You see 1, 2, 3 only. Study cases for workover, pulling completion while the well is flowing. Sometimes you kill the well, but the well flows by itself. What shall you do? You have to take action. The respected companies that respect themselves don't allow you to pull the completion while the well is flowing. This is totally wrong. You are not allowed to do that. So if you work, for example, with Shell, there is zero blowout. It is not allowed for you. But other companies, they don't care. Okay, they tell you stop for 1 hour or half an hour, then continue pulling. This is rubbish. That is not good. So many incidents happened and many people were killed or injured or the rig was fired or something happened to the environment, to the people, to the assets, equipment, to the company reputation. So it is not allowed to do like this. So some companies are working like this. So I focus on this, and that is not allowed. This is against the procedure. Also, fire on rig. Sometimes we work with gas flowing from the well, and in this case, we have fire when there is any friction between 2 pieces of metal. Fall down of a rig during operation. The rig is like this, suddenly like this. It sleeps. Why? Because something in the base, maybe something not good in the rig up, it goes like this. I know one rig, the derrick man was here and it went like this. He died. This man died while they were working. Losing of well control. Also, we can talk about many wells. For example, Deepwater Horizon in the Gulf of Mexico, we see that the well spilled 82 days of about 5,000 barrel oil per day into the Gulf of Mexico. It was the biggest disaster in the whole oil industry in the world. So we want to avoid such incident, and BP was in bad shape. They lost billions and billions of dollars. This incident occurred in 2010 in the Gulf of Mexico, and 7 people died and many were injured. The environment was in very, very bad shape, and we don't want to reach to this case. I will explain to you what happened exactly, and you will find it very easy. Broken leg or injury of a workover on the rig. I witnessed that also. One of the workers were working, and a drill pipe fell on his leg and broke it. This is damaging the personnel on the rig. Smelling of H2S getting out of the well, also H2S hydrogen sulfide. It can kill the people between 700 ppm and 1000 ppm. I was working in Abu Dhabi. We were having the highest H2S percentage in the world, almost about say 37%. What does it mean, 37%? 370,000 ppm. If I tell you 700 ppm can kill a people, can kill a man, while 37 or 36%. Every 1% equals, write it down with you, please. Every 1% of any gas equals 10,000 ppm. 10,000, 1%. So 37% means 370,000 ppm. It is terrible. It is not easy at all. Also, there was incident. I will show you a video. 4 guys were killed also for some companies. They issued a video to highlight the hazards of the hydrogen sulfide, how we can control it, how we prevent this incident, and so on. It is very important, and if you visit my YouTube channel, you will see it, and you will be very interested, and you will get benefit from it. Here, let us move to HSE, Health, Safety, and Environment Information. We can talk about OSHA. This is OSHA, American Certificate for Safety. IOSH, this is British from UK. NIBOSH, also British. Incident investigation, I will tell you about techniques. How can we do incident investigation? Managing safely, main HSE principles and procedures, how to prevent incident by proactive, not reactive, proactive. Before the incident occurs, you would put all your controls to avoid or to prevent this incident to occur. So you have always to be proactive. Every one of us should have safety like this, not like this. You don't tell me that I am drilling engineer. Finish. You are safety also. You should have safety at least 70% or 90 or 100%. Without safety, you cannot work. So we can focus on the safety. Many incidents occurred due to the ignorance of safety by the personnel. Why? It is very easy. Or within this course, you will be expert in safety. Safety is the work of everybody. Put it like between brackets. Safety is the work of everybody. So you have to learn and improve your knowledge, improve your experience. So incidents occurred with us and investigated it, lessons learned. I in some period, I was responsible for safety, senior safety engineer for 2 years. So many incidents happened with us in my company, and I will tell you the lessons learned from these incidents and how to do incident investigation, how to collect data, how to ask, how to write your report, and so on. Here, if you want to go to one by one, just to go through the presentation, and when we are talking, I will let the last part of the session to you for discussion and experience exchange. I know most of you have high experience, and we can make experience exchange, if you don't mind. So here, introduction to oil industry. When you say oil, means gas, inclusively, oil and gas, or we say oil industry or oil and gas. Well, life cycle stays, seismic method, exploration of hydrocarbons, IWCF certification, drilling rig types. We can look at it very fast, how the oil was formed in the last hundreds of millions of years. We will take an idea about it. How can we discover it using the seismic method by sending sonic waves, and it will reflect from the surfaces of the rocks that contain these hydrocarbons, and then we can move the drilling rig and drill a well. This well either has oil and gas or dry. If it is dry, then you do your best. If it is having oil and gas, then you can drill another one, second, third, fourth, and so on. So we have many types of wells. The first one, we call it exploratory well. We can select it based on seismic data or survey. When we find hydrocarbons, then we go to development well. That is you drilled afterward, exploratory discovery site. After we discover the hydrocarbons, we can select another locations close to this well or away from it. It depends, and we can depend on the seismic data. Here, what is the definition of oil well? This one, and what is the definition of gas well? Gas well that is designed to produce mainly gas. Sometimes maybe this gas is associated with oil. So gas and oil here. For your information, oil cannot be present alone without gas. That is seldom, rarely. But gas is always associated with oil. So either this gas is this gas percentage either high or low. It depends on the reservoir and the hydrocarbons that are available in this reservoir. Now we move to well life cycle. Either we can take this one or take this one. You see drilling from the beginning, drilling, then completion, then drilling includes drill and run casing. Then run the completion or tubing with packer, with pack completion accessories. Then production, do perforation, stimulation, and lift the well. This is intervention or maintenance using wireline, coil tubing, slick line, intervention, well testing, all of them. Then at the end, plug and abandonment. This plug and abandonment, every one of us has a limited life. So either 50, 60, 70, but cannot live for 1,000 or 2,000 years, right? The well is like this also. It can die, and we can close it using a plug and abandonment with 3 plugs of cement. And we can isolate the well and remove the Christmas tree and keep it alone like this, as if somebody died. They put like a stone or like this, and we put a small piece of metal like this and say, here there was this well. Or in other words, you can say design, construct, operate, maintain, and abandon. You see, this is the well construction in the beginning. That includes drilling and completion. Then production, then maintenance. Maintenance includes either workover that can continue for tens of years. What does it mean? For 30 years, 20 years, maintenance. For example, the same as a human body. Now, you are 25 years old or 30 years old. You are not exposed to diseases, to problems, pressure, sugar, like this. But after 10 years or 20 years, it is mandatory that you have to go to the doctor. Why? To do a blood test, sugar test, everything, X-ray, like this. And the well is also same as this, same as a human body. You have to do a pressure, temperature survey, PLT. You have to do well testing. You have to take sample, blah, blah, blah. All of them are maintenance operations, either workover or the other ones. For example, when you run in the beginning, the completion was 4.5 inch. But by time, the production dropped from 5,000 to 2,000 barrel per day. In this case, it is not economic, and the well may have some problems to produce using 4.5 inch. What shall you do? You have to move workover, and you retrieve the completion 4.5 inch, and you can run 3.5 or 2.78 or 2.38 and run the well again. You can produce here 1,000 or 2,000. In the beginning, it was producing 5,000 or 10,000 PSI. I know in Kirkuk, in Iraq, they produce from the casing, 9 and 5/8 inch casing. You imagine, it produces about 20,000 barrel oil per day at shallow depth, maybe 400 or 500 meters. That is ridiculous. It is very, very fine. And the economy of this well is very, very good. So, but by time, you have to, the production, it goes like this, then declining like this. In this case, you have to do something, either you call it production reservoir, you call it reservoir maintenance. What does it mean, reservoir maintenance? By supporting the reservoir pressure by drilling water injector wells around this well, either 4 wells or 2 wells or 1 well, or there is something, we call it the reservoir engineering. They can tell us, you have to drill here, drill here, drill here, and then we can pump water or CO2 or gas or whatever, or why? Just to do support for the reservoir pressure. At the end, we don't produce anything from the well. What shall we do? May Allah mercy him. Bye-bye for this well. We do plug and abandonment. It died. Very nice. You see the period of this, the drilling. It may take about not 2 weeks, maybe 2 months, 3 months, like this, drilling. Then production and completion, you see. Then maintenance or production for 20 to 30 years. So this is included under the umbrella of well intervention. well intervention. The drilling can work for, say, 1 year or 2 years, but you are working for 30 or 50 years. So this is very important stage in the well life cycle. So we focus on it and we deliver such long course just to make you expert and you can know what to do in case the well becomes old. Same as you will become old someday. All of us are now young people, but after say 20 or 30 or 50 years, will be same as this well. We need to measure our blood, blood pressure, sugar, X-ray, and so on. Why? Because if you have any problem, in this case, you can do action or take medicine or do whatever. Why? To extend your life. Mr. Muhammad, you can write down your question and I will answer you. Please. You go to the doctor, he tells you you have this problem, you have to take this medicine or do this operation. Same as this one. When we look at the log in the well, we conclude that the well is having this problem and this problem. We have to close this zone and open this zone. The tubing is parted and so on. We have high water cup. We have high GOR. The reservoir is depleted and so on. So we are same as doctors. We are doctors in oil and gas wells, but the doctor is doctor for us, human beings. So this is the difference, but the same principle. Here, seismic also, we can go through it, seismic, and what is the principle of seismic? You see it here. You see we send sonic wave, and we have geophones here. You see geophones. So there is difference, delta T, this delta T between sending, then reflecting, then we can draw maps. These maps will enable us to know the shape of the rocks in the underground. Then we can guess that here we may find gas or oil. We drill only one well or two wells. We call them exploratory wells. Then if we find this oil and gas, then we can draw development well. We talked about it. All of these will go to the recorder truck here. This recorder truck will collect all of these data. We do data treatment or interpretation. It will give us like maps, seismic maps. It will tell us here there is possibility to find oil or gas. Here there is no possibility and so on. Here we are talking about geoseismic. We have seismic engineers also. I didn't work in this. I studied it in the university and later on I saw videos, studied more, but I didn't work any. But we can imagine it. You cannot work everything in your life, most of it. You see, this is offshore in the sea. You see, this is seabed and this is sea level. Sea level, and this is seabed, the ground. Here in Turkey, we found gas that is enough for Turkey for 35 years in the Black Sea. By doing the survey first, then we can go there. You see, then drill. We have many 3 ships that drill in the sea. Fateh, Yavuz, and the other one, I don't remember it. So now Turkey is a gas producer country. And we get gas now for 1 year, all of our houses free of charge. We don't pay anything for 1 year. This is coming from our government. So it is good. Here for IWCF, for well intervention, you have these two mandatory, two exams, mandatory here, completion equipment and completion operation. Then if you want to add wireline, if you are wireline supervisor or operator, if you want to, you can add this and this. If you want snubbing also, you can add snubbing. For me, I have certificate for five these. And to be as an instructor, you have to get 90%, 90 degree plus, from 90 to 100. If you get 89, you will not be as an instructor in this one. So you have to know more and more, because we are delivering courses always, and we have already experience from our life. So it is easy for us to get 100 or 95% or like this. So I expect that you will find it very easy for you by going through them one by one. So by the end of the course, you will be ready to attend IWCF, and you can be granted this IWCF by attending a course, then do a certificate. This certificate comes from the UK, not from me or from any company. It is only from Scotland, Aberdeen. So if you are qualified and you prepare yourself, calculations, all of these, so you will be granted this certificate from UK. And this will increase your value. So if you have IWCF, is different than you don't have just experience like this. That is not good. So you have to improve yourself, learn more, read, watch, attend courses like this to make your level from here to here. Then the next course from here to here, and so on, till you hit your head by the set. There are 4 levels of certificates. We have level 1, level 2, level 3, and level 4. Level 3 and level 4 are most famous. 3 for operators and 4 for managers and supervisors. Here some calculations. I will teach you about the calculations, how the formulas that we use. Here, all of them. I will give you examples also. You will see yourself going faster and faster, because the principle, you know it. So if you take now a photo for this, I collected the 7 formulas. Also, I can give you the API formula sheet for both drilling and well intervention, if you like. I give you kill sheet. I give you all of them. So just to improve your knowledge, and you will see yourself at a higher level by time. What about the drilling rigs? Also, we will see the definition, the types of them. We have these types, you see, land, rig, and offshore. Offshore has 4 types. You see them. This is land, and these are 4. These are offshore rigs, and every one of them is designed to drill at a certain depth between the sea level and seabed. This is seabed, and this is sea level. You see here for shallow water, for example, here till 500 feet, here till 10,000 feet, semi-submersible, and drill ship for example, Gulf of Mexico. It is deep Gulf. So we need more than 12,000 feet, up to 12,000 feet. So all of them will go through them. You see, this is land rig, this is onshore, and for the rest, offshore. This is jackup, and this is barge. You see, this is semi-submersible, platform, and this is drill ship. You see, this is Turkish platform, Turkish ship, drill ship. We call it Yavuz. Yavuz and Fateh. There is a new one, the third one. So it is very interesting, you see, very interesting. Now let us move on to well types. We mentioned exploration and production and vertical, horizontal, and deviated. Well types also, we have oil producer, we have gas producer, water injector, gas injector, WAG, we call it WAG, this is injector well. Water, alternative gas. 6 months you inject water, and then 6 months you inject gas. Water supply well and water disposal well. Here, the completion, what is the profitability, what is the criteria of the completion design. Before 25 years, I attended course was called completion design. That's it, completion design for 5 days. How to design the completion, what are the components of it. So I will spend with you a good time for this completion also. What are the objectives of the completion? We will go to them also one by one. You see the types, it depends on the formation. Here, open hole. You see, here, cased and perforated. You see, perforated casing completion, this one. Here, for hard formation, we run it. While here, for soft formation. But here, there is no contamination, no damage to the formation. While here, we have cement, we have casing, we have like this, but 99% of our wells worldwide are similar to this form. This, you see, cased and perforated casing. We have either single or dual. You see, this is dual. This is dual. We have top zone, we have bottom zone. Sometimes we have 3 zones, top, middle, and bottom, and so on. We call it multiple. I worked in UAE. We were having about 30% of our wells were dual. You produce 1,500 barrel oil from top zone and 2,500 barrel from bottom zone. So you produce 4,000 barrel per day of oil every day. From short string, we call it this one short string and this long string. So you can control it, and it is not very difficult. It is very easy. Just you apply the company procedures, then you can work safely, and there will be no problem. You see, single completion, single selective, dual completion, dual selective. We will see them. This is single vertical well, this one. This is single selective, top zone, middle zone, bottom zone. So either you produce from 3 or from 2 or from 1. Dual, short string and long string. What else? What is this one? This is single slim hole. We don't run completion accessories because the reservoir pressure is very low. And in this case, we prevent or avoid any obstruction in front of the formation that will prevent it from flowing freely. What else? We have here vertical, you see, this is packer, this is completion, this is SSD, sliding side door, top packer, middle packer, bottom packer. We have perforation. While here we have open, we have horizontal well. This is vertical well, this is horizontal well. Also, what do we have here? Side pocket mandrel, you see it. This is gas injection well, you see, not gas injection. We produce the well using pumping gas lifting, by gas lifting from here. I will explain to you what is the principle of gas lifting by using the side pocket mandrel. And we have 3 types of gas lift valves that can be set in the gas lift mandrel here. And we produce the well-being. Why do we run such completion? Because the reservoir pressure is low, so it is not enough to flow the well from the reservoir to the surface naturally. So we need artificial lift. This is type of the artificial lift. You see, the artificial lift, we have 4 types. Gas lift, that which we mentioned, and gas lift mandrel. We mentioned that. You see it. Look at here. Gas lift valve, gas lift valve. Here, for example, 500 feet, 1,000, 1,500 feet, and so on. So when we pump gas from here, it will produce like this. When we pump gas and produce gas, this will close and go to the bottom one, and so on, till we produce pump gas and produce gas. At this stage, what shall we do? We have to stop, allow the well to build up. It will, we stop, for example, pump for 1 day and stop for 1 day to allow the well to build up. Build up means this oil that is available in the reservoir, it goes up here to here, for example, till 500 feet or 1,000 feet. Then using pumping gas, by gas injection, it will help us to get this oil to surface. Okay. The other type is ESP. This is ESP. You see it by pumping the pump. You see the pump, this one. And here we have gas separator. Here we have the well, this one. Here we have motor. We operate the motor using the electric cable from surface to motor, and this will allow the well gas to be separated here, and the oil will enter to here. You see, till surface. We have beam pump also, or Sukhri here. Sukhri pump. If we have a high production rate, for example, 10,000 barrels per day, 8,000 barrels per day, we can use this one, ESP. While here, we use it if the production rate is between 500 to 1,500 maximum. So if it is more than that, then you need ESP. If 10,000, it cannot produce 10,000. This is working either continuously or repeatedly. Also, we may have also to stop the pump for 1 day and operate for 1 week, or 1 day by 1 day, and so on. Here we call it PCP, progressive cavity pump. This we run it with heavy oil reservoir. Here we have a stator, and here we have rotor, and we have this Sukhri. You see, Sukhri and coupling. Between Sukhri, we have coupling. Sometimes we were having this is cut. So we move the work over rig, and we fish it and replace it and pull it. The motor also can be damaged, prime mover, and we have here the wellhead and the clamp here. The completion also, we can see the completion. We still have 13 minutes. I will stop after 13 minutes for your questions. Here are the completion components. We have the casing, we have the packer, and the tubing. We have completion accessories here. We will go through them one by one. It is very important for you. You see completion from bottom wire entry guide till tubing hanger and Christmas tree. All of them, we will go through them. You see, this is back pressure valve, two-way check valve. You see, tubing hanger, and this is a cross section of the tubing hanger. We go through them one by one. Subsurface safety valves also, the types, surface controlled and subsurface controlled. We have tubing control line. You see it here. We have the subsurface safety valve. Either can be controlled from surface or using the control line. Control line is normally 1/4 inch stainless steel 316. If you write it down, please. This is the specification of the control line of the subsurface safety valve. Stainless steel 316 1/4 inch. It can transfer the hydraulic pressure, hydraulic oil from surface to the subsurface safety valve, either to open or close. You see, here we have either wireline retrievable or tubing retrievable. Tubing retrievable can be run with the workover, while wireline retrievable can be run with wireline unit. And this is the most important safety device in the well that can close the well in case of an emergency, in case of fire, explosion, earthquake, anything. It can close the well and safeguard it. You see, this is the subsurface safety valve. I can show you videos also, how it can open, how it can close, and so on. You see, this is the flapper, this is open, this is the flapper, this is closed. And how we transfer the hydraulic power or hydraulic fluid from surface to open this flapper. Here, production string, the specifications also, and how should be they, the tubing size, the material, what are the components of the reservoir fluids, the depth, the size, the connection, the coupling, all of these, we have to know about them. So here, if you want to go to liner, you press control and go to here, you go to everything about liner. Here also about this one, you can go to it. Completion, corrosion, erosion. What is the difference between corrosion and erosion? I think the corrosion and erosion, this is mechanical, and this is what? This is chemical, or during, for example, H2S with metal. This is can be considered as what? As a chemical, while erosion is mechanical. Look at the water in the valleys when it rains. It sweeps the soil. You see the soil, it sweeps it. This is called as an erosion, we call it. And so on. We will talk about them, all of them. These are the tubing and couplings, all of them. This is a short section. You see it. Normally, we have three sizes or three types, categories of length. But the most length is 10 to 11 meters. The packer also, we have production packer, we have permanent packer and retrievable packer. We can go through them also, you see, and single packer and dual packer here. Completion also, landing nipple. What are the types of landing nipple? Selective and no-go. You see, and ported safety valve nipple, landing nipple, selective nipple. Here, circulation devices, we have two types, side pocket mandrel, sliding side door, and side pocket mandrel. We will go through them. This is SSD, sliding side door. You see? I will explain the principle of the side pocket mandrel and, sliding side door, and about the side pocket mandrel also. This is side pocket mandrel. You see this one. Kick over tool. We can run and pull what? kickover tool for the gas lift valve. You see it? Gas lift valve. We can use it using wire line. You see? Flow coupling. Why shall we run it in the well also? Flow coupling. Polished bore receptacle. BBR, we call it. Tool travel joint. You see? Wire entry guide, the last piece in the completion. Wellhead, you see the wellhead also here. The types of the wellhead, you see. A Christmas tree, we have two main types, conventional and monoblock. So this is conventional, this one, and this is monoblock. One part, one piece. This is conventional, the green one. And we have compact or subsea. This is offshore. I will show you. You see, this is compact. It is difficult and not easy for you to understand it because you don't work as a subsea engineer. You see, this is subsea. This is dual, short string and long string. You see, this is the flow line of the short string and this one. This is beam bomb, the stuffing box, and we have here the annulus, and here we can produce, and polished rod, this one. And we can monitor the pressure. This is ESP. You see ESP because there is a hole to run the electric cable here inside it. The origin of oil also, we will talk about it. The origin, how was it made? Millions of years ago. Here we have a reservoir rock, cap rock. What are they? You see, reservoir rock, cap rock. Where is it? Cap rock. This one, cap rock. You see, this is reservoir rock. This is source rock. Here where the hydrocarbons were formed. They move up till here. The gas will go up and oil below it and water below it. And we have many types of the hydrocarbon traps. You see this trap? This one. So we have different types of traps. You see? This is. So when you drill here, you will see gas cap. When you drill here, you will see oil. When you drill here, you will see water. So the imagination or drawing of the reservoir boundaries, it will give you an idea. You see the hydrocarbons were formed here in the beginning, here. Then they moved up through this fold and up to here. You see, source rock is different than the reservoir rock. Natural gas, oil, and water. So different reservoirs. You see here, how can we drill? Deviated well, horizontal well, vertical well, the reservoir, salt, shale, and so on. The porosity and permeability also. What is the meaning of porosity? What is the meaning of permeability? You see, this is porosity is the percentage between the for reservoir pores to the total volume of the reservoir. I think you know it. So it may be 5%, 20%, and so on. But in general, between 5 and 40%. While the permeability definition is the ability of the reservoir to allow the fluids to pass through it under a certain differential pressure between it. Okay, and we measure it by millidarcy. This one millidarcy permeability. While this one by percentage. Phi porosity means the pore space volume of the bulk volume of the rock. So this is percentage. Why this one millidarcy? This one. Hydrocarbons also here. What are they? They are carbon, 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 hydrogen, 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 and so on. You see it? So either it is light, natural gas, or condensate. This is light also, and petroleum is more heavy. We'll talk about bubble point. Let us pass fast. The solution, the mechanisms of reservoir production. So we have solution gas drive, gas gap drive, depletion drive, water drive, gravity drainage drive, and combination of one or more from these drives. You see? Here, crude oil specifications. What are the specifications? We watch the news. They tell us West Texas Intermediate and what? Brent. So what are they? I will explain that to you. The density, what is the density of the oil, crude oil? What is the specific gravity? Also here we can measure the specific gravity. You see, we have API, American Petroleum Institute gravity. We will measure it here and see how much. As it is high, then it has more value, API. So the API of the water is 10. But for the brine or mud, it is 6 or 7. But for the oil, it is about 25 to 30. But for condensate, it is 40 plus. Condensate is very, very expensive. We can sell it with high value. API, we will go through it also. You see it here. Here, Boyle's law, P1V1 equals P2V2 for general gases. You see, this one also, pressure and temperature opposite to each other. Here, production stage also. I will just pass through it one by one. This is well testing. You see West Texas Intermediate and Brent. And there is Dubai crude also. You can go through them. If you press here, you will take all data from it. You see, this is Brent, a small field in the North Sea, close to Norway. They took sample and they make it as benchmark. And here, West Texas Intermediate in the US. Reservoir monitoring also. These are well testing here. This is wireline. Standard wireline. The tools, you see, wireline tools, braided line, perforation. This is braided line and electric line, coil tubing. We can go through it, also cement, acidizing, frag, acidizing. You see, all of this only for this well. You see this well? Frag. Imagine. Scale and sand, milling, you see, milling, fishing, pumping, wellhead, maintenance, workover. We go to workover, you see, these workovers. Well kill methods. You see how to kill the well. Well logs, types of logs, noise log, working in H2S environment. What are the specifications of H2S, hydrogen sulfide norm? This is radiation. What is hazard? Risk, what is risk? Controls also. Permit to work system. Skin factor. Barrier theory. Hydrostatic, mechanical barrier classification. You see all of them. Well integrity management system, WIMS, we call it WIMS. Oil production. CO2 injection. What is corrosion? Cathodic protection, HSC incident prevention. Now here, the zone classification, hazard zone classification, unsafe act, unsafe condition, near miss, personnel protection, PPE, personnel protection equipment, PPE, you see. Golden rules here for safety, incident prevention, incident management, Macondo well, you see, this is in the Gulf of Mexico, Deepwater Horizon or Macondo well. Here, the incident happened here in the Gulf of Mexico. You see, this is Cuba, this is Florida, and here is Texas and Houston. Also, you see here, they drilled two relief wells, and they controlled. After 82 days of blowing, you see blowout in 2010. They drilled two wells, relief wells, and then they controlled it. H2S, you see. This I worked in these fields in UAE, in Abu Dhabi. So it is interesting. I can share some of my knowledge to you. Problems also, scale, hydrates, you see, paraffin, asphaltene, study case, abandonment. Here we put three cement plugs, here, here, and here, like this, as if died man, you see. That's it. Thank you for your attention and hope you get some of our